Welcome to Raid Planet Odyssey, a thrilling journey to Mars that will leave you fascinated and inspired. Join us as we explore the fascinating world of Mars exploration. From robotic rovers to human dreams, get ready to blast off into the unknown, discover breathtaking landscapes, and uncover the secrets of the Martian surface. Your cosmic adventure awaits. Let's embark on this thrilling journey together. Imagine standing on the rusty red soil, gazing up at the crimson sky. Mars, the unforgiving yet fascinating neighbor of Earth, has captivated human imagination for centuries. In 1964, NASA's Mariner 4 spacecraft flew by Mars, capturing the first close-up images. The world marveled at the Valles Marineris, a massive canyon system stretching over 2,500 miles. Fast forward to 1975. The Viking missions revolutionized Mars exploration. Viking 1 and to search for life on Mars, sending back valuable data and images. Today, NASA's Curiosity rover is the ultimate Martian explorer. Weighing 2,000 pounds, it's a robotic geologist analyzing rocks and soil. Launched on November 26, 2011. It landed on August 6, 2012. Using the innovative sky crane technique, Curiosity discovered evidence of ancient lakes, organic molecules, and methane. Its breathtaking images make us wonder, what secrets lie beneath Mars' surface? From the towering Mount Sharp to the sprawling Gale crater, Curiosity continues its journey. Newer missions like Perseverance and InSight join the quest. Perseverance searches for signs of past life, while InSight probes Mars' interior. Imagine walking on Mars' surface, feeling the Martian sunrise paint the horizon with hues of crimson and gold. Mars beckons, and we're answering. As we explore, we uncover surprising similarities between Mars and Earth. Both have polar ice caps, seasonal changes, and geological activity. NASA's Mars Reconnaissance Orbiter reveals stunning views of Martian landscapes. The high-resolution imaging science experiment camera captures images of unprecedented clarity. We see ancient riverbeds, volcanic eruptions, and shifting sand dunes. Future missions promise even more excitement. NASA's Artemis program aims to return humans to the Moon and eventually land on Mars. Private companies like SpaceX and Blue Origin are also racing to the Red Planet. The Martian dream is within reach. Join the cosmic journey to Mars and discover the wonders waiting to be uncovered. The Red Planet's secrets await, and we're ready to unravel them.
exploration of Mars bears great significance in many respects. There might once have been liquid water on the Martian surface, providing an appropriate environment for the development of life. Furthermore, the planet might be suitable for establishing human colonies. Traces of Martian water and life have been intensively sought since the 1970s. The first photos of Mars were taken by the American Mariner 4 space probe when it flew by the planet in 1965. Mariner 9, launched in 1971, was the first spacecraft to enter orbit around another planet. Between November 1971 and October 1972, it took over 7,000 photos of the Martian surface, atmosphere, and moons. It discovered several terrain features such as dry riverbeds, canyons, and the 25-kilometer-tall Olympus Mons, the tallest volcano in the solar system. During the years of the Cold War between the US and the Soviet Union, space exploration played an especially important role in the competition between the two superpowers. NASA, the US space agency, succeeded in delivering the descent modules for the Viking 1 and 2 space probes, while similar attempts by the Soviet Union remained unsuccessful. The Viking probes examined the atmosphere, climate, and surface for years. They also searched for traces of life, but the results were inconclusive. The next generation of instruments to examine Mars were Mars rovers. The Pathfinder space probe, which carried the first Mars rover, landed on Mars in 1997. Although the vehicle was designed to function for 30 days, it lasted for 3 months. In 2004, twin probes were launched to Mars. The Spirit and Opportunity rovers sought evidence of water on the red planet. They were originally designed for 90 days, but Spirit traveled 7 kilometers in 7 years, sent 124,000 pictures, and analyzed 93 rock samples before becoming stuck in a sand dune. The main purpose of Curiosity is to locate possible traces of water and life on the surface of Mars, as well as to carry out planetary habitability studies in preparation for future human exploration. The Curiosity rover was launched by NASA on the 11th of November 2011. The rover successfully landed on the 6th of August 2012 in the 150-kilometer-wide Gale crater. The landing was completely automatic, extremely complicated, and risky. This is why it was called the 7 Minutes of Terror. When the descent module entered the Martian atmosphere, it lowered its speed. At an altitude of 10 kilometers, the supersonic parachute opened. Then, at 7 kilometers, the heat shield disconnected. When the speed was low enough, the protective shield also disengaged. The Sky Crane continued the descent and lowered the Mars rover onto the Martian surface from a height of 20 meters. Curiosity analyzes rocks with its high-tech instruments. These include the ChemCam, a chemical camera that shoots infrared laser beams at the rock it examines, thus causing a small amount of the material to evaporate. The camera then examines the composition of the resultant fumes by spectroscopy. In September 2012, Curiosity found an ancient riverbed, which provides proof of past water activity on the surface of Mars, a prerequisite for the emergence. Mars was one of the oldest gods of Rome. The first observers of Mars were the ancient Egyptians. They referred to it as Horus of the horizon. Besides the Egyptians, the Greeks were also busy observing Mars. Around 300 BC, Aristotle noted that Mars was farther from the Earth than the Moon. At the end of the 16th century, Danish astronomer Tycho Brahe managed to plot the path of Mars with the greatest accuracy to date. His assistant, German astronomer Johannes Kepler, based his first 2 laws of planetary motion on observations of Mars. The orbit of each planet is an ellipse, with the Sun at one of its foci. The line joining a planet and the Sun covers equal areas during equal intervals of time. The planet moves faster near the Sun, and it moves more slowly at larger distances. Since 1877, when Schiaparelli announced the discovery of a network of lines on the surface of Mars, the planet has been the subject of much debate. Many believed that the network was a man-made system of canals. Subsequent observations have disproved this idea. The first space probe to visit Mars was Mariner 4 in 1965. Later, dozens of Soviet, American, European, and Japanese spacecraft, orbiters, landers, and rovers, were sent to Mars to study its surface and climate. Of these, the most successful were the Mariner and Viking programs, the Mars Global Surveyor, the Odyssey, the MRO, the Phoenix, and the Mars Express. The Pathfinder, Spirit, and Opportunity rovers have provided a great deal of information while moving along the surface. Mars is the fourth planet from the Sun in the solar system, the outermost of the inner planets. It is 1.52 times as far from the Sun as the Earth. Its diameter is about half of Earth's. Its mass is only a tenth. It is a rocky planet, or terrestrial planet. The surface of the northern hemisphere features huge volcanic cones and shield-shaped volcanic mountains, while the southern hemisphere is covered with old impact craters. The craters, measuring more than 300 meters, and sometimes several hundreds of kilometers in diameter, were probably created by asteroid collisions, which is not surprising, as the asteroid belt lies near the Martian orbit. The southern hemisphere of Mars features several large circular basins, of which Hellas is the largest, with its 2,000-kilometer diameter. Its red color is due to sand and dust rich in iron oxide. The largest volcano on Mars, Olympus Mons, is a large shield volcano with a height of 25 kilometers. Valles Marineris is a canyon system lying 4,000 kilometers south of the equator, with a maximum width of several hundred kilometers and a depth of 6 kilometers. The region of polar snowcaps is particularly interesting, where hundreds of craters are filled partially or completely with frozen water ice and dry ice. Currently, there is no liquid water on the surface of Mars, but evidence shows that there has been in the past. There are topographical formations similar to dried-up riverbeds and drop-shaped debris deposits, which are typically deposited by fast-flowing rivers carrying sediment around landmarks. The atmosphere on Mars is very thin and is composed mostly of carbon dioxide, 96%, with nitrogen and argon, and traces of oxygen and water vapor. The atmospheric pressure is about 1% of the Earth's. If one were to stand on the surface of Mars, the sky would not appear blue, as on Earth in clear weather, but rather pale orange or pink. Weather conditions are harsh. The average temperature is 63 degrees below 0 centigrade. Thus, the polar regions are covered with carbon dioxide snowcaps. Martian years are roughly twice as long as Earth years. Seasons are also twice as long as on Earth, and much more extreme than here. During the winter in the southern Martian hemisphere, the polar ice cap might cover half of it, while in summer, the ice cap might completely disappear. A similar phenomenon can be observed in the northern hemisphere. The Martian magnetic field is very weak. There are two known moons, Phobos and Deimos, which are irregularly shaped and are probably captured asteroids. Both satellites were discovered by Asaph Hall in 1877. They were named after characters in ancient Greek mythology, the sons of Ares, god of war. The meaning of their names is dread, Deimos, and fear, Phobos. Completing an orbit in approximately 8 hours, Phobos orbits Mars faster than the planet itself rotates. Tidal forces are continuously reducing its orbital radius, and thus Phobos will eventually crash into the surface of Mars. Its surface features craters and grooves, suggesting a layered structure. The orbit of Deimos is slowly expanding. Its dark surface is covered with a thick layer of dust.